Hello students, let's read the problem. And it says, which representation does not show y as a function of x? So we're looking for a representation, right, that does not show, make sure that you guys read that word very, very carefully, okay? So it says, does not show as a function. So I'm looking for something that is not a function. Very good, okay? So let's take a look at my answer choices, right? And more than likely, you're asking yourself, well, but what is a function, right? So remember that in a function, every x value, it's paired with exactly one y value, okay? So we have some definitions over here in case you want to look over that one later on, right? So it just says that each input, of course, the x value, has one and only one output value, okay? So what we're going to do is we're going to look at my answer choices and we're going to look for the one, right, that x repeat means it's not a function. If it doesn't repeat, it's a function, okay? So we're going to write it down here. If the x values repeat, right, then it's not a function, okay? So that's the very first thing you got to remember, okay? So if the x value repeat, it's not a function. Let's look at letter A. And we're going to look at the x values only, okay? So I have -1 right here, -1, 0, 2, 4, and 6. Any of those values repeating? No, right? So this one is a function. Very good, okay? What about B? So we're going to highlight the x values, -4, -1, 0, 2, and 5. Am I repeating any x value? No, right? So this one is also a function, okay? What about C? I have -2/5, -1/5, 0, +1/5, and +2/5, okay? So not because you see the same numbers, 1 and over 5, it means that it's the same. One is negative, the other one is positive, okay? So am I repeating any of them? No, right? So this one is also a function. So it looks like D is the one that is going to be considered not a function. So how can I check though? Am I going to have to go and find all those order pairs? That's one choice you guys can do. And what do I mean by that? Like, for example, you can come back and say, what are the points for or the coordinates for this point? Give me the order pairs and then check the x values, right? That's one thing you can do. Or remember that in a graph, we can always check for the vertical line test. And what does a vertical line test prove? Okay, so in a vertical line, first thing is my vertical line should look up and down. So I am going to draw a vertical line, right? Hoping that in every single part of the graph that I draw the vertical line, it will touch a point only once, okay? For example, let's suppose I draw a line on the last point that is here. How many points are on that line? Only one, right? But that's not enough. You got to check the rest of the points. So I'm going to draw a line here. How many points are on that line? So I'm going to erase this one. How many points on that one? Just one, right? So let's erase that one. And now I'm going to go to the next point. What about if I draw a line right here? I can actually see 2 points on that line. Is that right? And if you really want to check if that's not a function, what about if we find the order pairs for those, right? For example, this point over here will be +1 and 2, 4, 6, right? +1, hold on, and +6. What about this point here? What will be the order pair for that? It's still +1, but now 1, 2, -3, right? Let's look at the x values. What do you notice? It repeats, right? It's the same 1, 1. That's why the vertical line test works. okay? And now you know that you don't need to find the order pairs. As long as you draw a vertical line, and if it touches the point once, it's a function. But if there's 2 points on that line, then that's not a function. So that will be my answer, right, guys? Because we're looking for something that does not show a function. So the answer for this, it is going to be D.